everybody, this is a video tutorial on our electric flexible heaters configuration tool. We call it the Flex Spec configuration tool, and it allows you to design a custom flexible heater for a wide range of industrial and commercial applications. Whether you're an OEM or an engineer or even a designer exploring ways of incorporating heat into your product, this video will cover the fundamentals of how you can do that through our system. We also cover each of the material's key features and advantages that they offer. This is the Farnham Custom website. You can get to it by going to farnham-custom.com. We have our standard product offerings. And each one of these offerings has several types of heaters within it. We also can help you with a custom heating solution. And then there's a lot of other resources that are over here that you can explore as well. Today, we're going to be talking about the flexible heaters. There's some information here about the flexible heaters we offer, specifically silicone, polyimide, and mica as the base material for the electric heater. You can read about the different types of heaters. You can also go over to get a quote. And this is our configuration tool and what I really wanted to show you guys today. The first thing to mention is the advantages of each type of material. Silicone heaters are favored for their durability, their resistance to physical damage, and their low wear and tear under high usage. Since they can withstand mechanical stress better than some of our other materials, they're ideal for industrial applications. Silicone also features moisture resistance and is ideal for wet or humid environments. So it has a thicker insulation layer, which means it provides better protection for the heating elements, especially in those harsh conditions they can be in. They can handle a bit higher a temperature over polyimide. They also maintain their flexibility really well, even at lower temperatures. Silicone is typically a very cost-effective option. Then we have our polyimide option. Polyimide heaters are thinner and lighter than silicone heaters. If you have limited space or if weight is a factor, consider a polyimide as a potential solution. Polyimide heaters have flexibility in addition to being thin. Mica heaters are also thin, but they lack that flexibility. Polyimide heaters also offer excellent thermal efficiency. The heat transfer is very good, and that's because of its low thermal mass, and it allows for rapid heating and cooling cycles. Polyimide heaters offer excellent electrical insulation properties, even at higher temperatures. The last option we have here is mica. Mica heaters have a higher temperature tolerance. Mica heaters offer excellent structural stability and natural resistance to moisture, chemicals, and even high pressure. Mica heaters are abrasion resistant as well, which can be a very good trait. They're generally more cost effective, especially for high temperature applications compared to polyimide heaters. Mica heaters offer excellent thermal conductivity with even heat distribution. So if you need absolute even heat, a mica based material might be the solution for you. Mica heaters also have a long service life and they degrade at a slower rate than, let's say, silicone. Before configuring your heater, consider these application details that could impact the type of flexible heater that you need. What surface will the heater be used on? Is it curved? Is it irregular? Does it need to flex and move during use? What material is the surface you're heating? There's metal such as stainless steel, aluminum, or copper. We also can use these heaters on plastic, including ABS, polycarbonate, and acrylic. I've seen these used on glass like soda lime glass or borosilicate glass. Something a little bit more common is ceramics like porcelain, alumina, or zirconia. And there's composites including carbon fiber or fiberglass, and even textiles like polyester, nylon, silicone coated fabrics. There's also elastomers, silicone rubber, EPDM, neoprene, and even paper or cardboard are surfaces that these could be used on. So just consider what material these heaters will be used on and make sure and let us know in the notes when you're submitting. Under Save and Send, there's an area for project details where you can add that information. Okay, so now that we've gone over some of those key elements, let's go ahead and configure this heater. What I'm going to do is configure something that we typically see from our customers. I'm going to go ahead and go with a silicone. Let's say we need a lot of flexibility in our application. Very common to see 120 volts and anywhere between 50 to 250 watts. And by the way, our configurator, if you're within a set of parameters that is not going to really fit for the heater, we are able to kind of give you a warning about that. And you could always talk with one of our engineers. You're just going to submit this and request to talk to somebody, and the engineer can kind of work with you on what your needs are going to be. Okay, so we're going to go ahead and configure something that's a little bit more standard. We'll say 120 volts, 150 watts. We'll also go to something more of a 16 by 12. This is arbitrary for demonstration purposes, but you could see as the sizes are adjusted or as the parameters are selected, the visual here is updated as well. Don't worry if you need your leads to be longer, if you need a different terminal, if you need some accessories, that can all be configured in additional steps. By the way, this is a good time to mention we can do imperial or metric version of the measurements. So we do millimeters or inches depending on what your needs are. You just have to switch over right here to whichever standard you need, and you can configure your heater in those measurements. But for now, let's say we're going to want a rectangle with a hole, and we're going to go 17, and we can also say how big that hole is going to be there. But yeah, there are all these other shapes. So we can go over to a polyimide solution. We can explore what a cone would look like. If you have a different shape, you could do star, 8-sided star. Yeah, so you can see how this can be used effectively for your needs. All right, so once you have your volts, your watts, your size, and all of your parameters selected, you can go to continue. So now we're going to go to our sensors and controls. Our first option is an MC5A temperature controller. This is pretty standard for us. Once selected, it reveals a few other options. Right now we have 18-inch Type K fiberglass. And I believe the connector can either be stripped leads or the mini K connector. Right, so strip leads kind of gives you the open-endedness to put your own connector as needed. And then the attachment method is going to be either vulcanized to metal or pressure-sensitive adhesive. So whatever your needs are there, or none if you're going to have your own attachment method. So we go ahead and configure all that and select continue. Now we're going to talk about leads and connectors. So our lead can be on the inside or on the outside. And so we have it on opposite ends, standard, which is just on one end, or you can have it on the inside, which in this case is pretty much in the center there. And then your lead type is extruded silicone rubber or PTFE Teflon, right? So if you need silicone or Teflon, just select that from there. And then your lead length. So you can go all the way up to 18 inches standard. And if you need, you can go to other and you can specify your length. And then we have connectors. We just have this connector for now. So we will select that and we will continue. Estimated annual usage. This is the EAU. And it helps us understand where it would be better to manufacture your order. Your initial quantity. So you can start with MOQ of 100. And then as your needs grow, you can come back and order additional. And then your lead time requirements. So if you have UL requirements, you can list it here. And we're going to select continue. So now we're at the save and send. We're going to do our GDPR acknowledgement. That's just a standard for European website visitors that we are in compliance and that you are accepting our terms. Then there's the opt-out. I would highly encourage you to leave it unchecked. We send great newsletters with tons of resources and articles from our engineers. Don't check that one. We'll go ahead and put your company name, customer name, and phone number. We'll go ahead and put in an email as well and an acknowledgement statement down below. Now, here's where you can tell us anything about what you need on the heater. Again, any of your details that come to mind, please let us know in the project details. Once we've selected all this information, we will go ahead and send it. You can send and build another. So if you need 3 different types of flexible heaters, you can just send it and then start building another one. If you are halfway through building the heater and you say, you know what, I really need to consult with some of the team members before I submit this, you can just select save. It'll save into your browser cookies. And then when you're ready, you can come back, launch the Flex Heater tool, and you can come back and configure some more. You can also export through this print function. So you'll be able to save it to a PDF for your own records. You could, of course, also print it to your printer. So as you can see, it's a pretty robust system. It can get 95% of flexible heaters that are needed covered just through the configurator. If you do need something that's more custom, we're happy to talk with you and explore what solutions will work for you.